Okay, this is section 2.7, graphs of basic functions. This is going to help you determine end behavior of a graph, the end behavior of a graph. So the first one, I gave you the identity function. It's known as f of x equal to x. Normally we see it as y equal to x. I'm giving you both scenarios, the positive version of it and the negative version of it. So in this one, we're going y equal to x, so we're rising from the third quadrant into quadrant 1. The domain and range is going to be from negative infinity to positive infinity for both of them. So as the x's become more negative, the y's become negative. As the x's become positive, the y's become positive. The negative side of it, the function f of x equal to negative x, or y equal to negative, is a reverse. It's a mirror image, but flipped over the x-y axis. So it's going from quadrant 2 to quadrant 4. So as the x's become negative, the y's become positive. So y is going from negative infinity to positive infinity. As the x's become positive, the y's become negative. So if we were asking the end behavior, as x goes to positive infinity, the f of x function goes negative. That is the decrease in functions. Quadratic functions, those are your parabolas, opening up and opening down. So we see f of x equal to x squared, or y equal to x squared. So it's a U-shaped graph. It has a domain from negative for the x's. As the U shape opens up, like a flower approaching the x-axis here, your x's are going to negative and positive infinity. Now the range is different. Because it is not crossing below the x-axis, it's bounded from the 0 up. So our range becomes a bracket at 0 going to positive infinity. The mirror image reflected over the x-axis, f of x equal to negative x squared, or y equal to negative x squared. Notice that it's opening down. The domain still is negative infinity to positive infinity, but the range is different. Notice that the y's stop at 0 and go to negative infinity. So when you write your interval notation for range, you'd go from negative infinity up to 0 with a bracket because it did not exceed the 0. It stopped at 0 and then came back down. So again, it looks like an upside down, like a rainbow. It opens up approaching the x-axis. That's why we get the x's going left to right. Cubic functions, the first one says f of x equals x cubed, y equal to x cubed. It looks like a half of an H, a cursive H here. So notice that it's going from quadrant 3 up into quadrant 1. When it is positive, it's going from quadrant 3 up into quadrant 1. So if I were to stretch my graph and make it parallel to the x-axis, the x's are going to negative and positive infinity. When we look at our y's, the y arrow is pointing down to negative infinity and up to positive infinity. So your domain and range are both negative and positive infinity. The reflection of that, which is the f of x equal to negative x cubed, or y equal to negative x cubed, notice it starts in quadrant 2 and goes into quadrant 4. So it's going, it looks like a vertical line, but it's curve shaped here because it's a cubic function. The domain, if I were to stretch it out, my x's are going to negative and positive infinity. The y's go from positive infinity to negative infinity. So this one does the reverse. So as x goes negative infinity, the y's go positive infinity. As the x's go positive infinity, the y's go negative infinity. This is end behavior. We're doing the end behavior pieces here. Absolute value functions. These are your V-shaped graphs. They mirror your U-shaped graphs. So the f of x is equal to the absolute value of x are known as y equal to absolute value of x. They look like a V. Opening up, and its reflection, the negative is on the outside of the absolute, not on the inside, it's on the outside, so it's opening down. So it does the same thing as the U-shaped graphs. The domain goes from negative to positive infinity, but the range, it's bounded by that 0, so it goes from 0 up to positive infinity. The reflection one over the x-axis, x's go to negative and positive infinity again, but the y values are from negative infinity up to 0. It's bounded by that 0, so that's why we wrote negative infinity to positive infinity. Negative infinity to positive 0. The square root functions. These are your square roots, your half parabolas opening to the right. Half parabolas opening to the right. So f of x is equal to the square root of x, or y equals the square root of x. Notice that it's bounded from 0 to the right. So when we write our domain in range, notice I did not go past 0 on the x-axis. It's from 0 going to the right. So that's why we are bounded at 0 with a bracket to infinity. The y values started at 0 and went positive direction, so that's why it's going from 0 to positive infinity as well. The reflection, or the negative side of a square root, because remember square roots have two sides, f of x is equal to negative square root of x. Y equals negative square root of x. So again, the x's, our domain, from 0 to the right, so 0 to positive infinity. But the y values, notice it's going negatively, but it approaches 0, so it's the reverse. It's from negative infinity to 0, and it stops at 0. The last group of functions are your reciprocal functions. So f of x equals 1 over x, or y equal to 1 over x. And these will be two graphs on the same graph line. You'll see two graph lines. Notice that this one, when it's positive 1 over x, we are in quadrant 1 and quadrant 3. Quadrant 1 and quadrant 3. Your domain. Notice that the domain, there are breaks. It's union pieces. We have unions showing up because the x's go from 0 to the right and 0 to the left. So we did not cross the 0. Your graph is going to approach the 0 but not hit it. That's why the domain for your reciprocal ones are from negative infinity to 0, the union 0 to infinity. Your y values your range, so as x gets to the right, our y value gets smaller, going up. And the same with the reverse function here. So as x gets more negatively, the y's can become more negatively or more positively, depending on which way you're going. So the range, again, negative infinity to 0, union 0 to infinity. The same happens with the reciprocal functions reverse, the mirror image. Your reflection, so it's f of x equals negative 1 over x, or y equal to negative 1 over x. Notice the difference between positive 1 over x and negative 1 over x. Negative 1 over x is now quadrant 2 and quadrant 4. But the domain and range stay the same. The domain, x's are going from 0 to the right and 0 to the left. So 0 to infinity, 0 to negative infinity. Hence why we are negative infinity to 0, union 0 to infinity. The range, notice that the y values are increasing and decreasing because it comes down. So it's going from negative infinity to 0 and then 0 to infinity. So for 2.7 notes, we're just understanding the basic concepts of M behavior. So this is something that's going to guide you with